Hey everyone, in this one I'm going to be solving topical past papers for the topic limits of accuracy, or as students like to call it, upper and lower bounds. And this is GCSE O level mathematics 4024, and you can see the reference of these questions right in this bracket on the top of each question. And if you have any questions regarding any methods that we're using in this video, or regarding the topic, or if you even want us to solve a past paper question or a whole question paper, on request we'll be doing that as well. Just post a detailed reference in the comments below so that we can address that need. Without further ado, let's get started. So we have 23 questions right over here, and I'm going to be going through all of them one by one. Question number 1. The length of a side of an equilateral triangle, equilateral is an important word, is given as 41 millimeters. Correct the nearest millimeter. Now anything next to this phrase right here, correct to the nearest, is usually and mostly the accuracy. And that is the accuracy at which we are estimating. So it's easier to calculate the error as well that can be made. The error can be calculated by dividing accuracy by 2. And the accuracy here is 1 millimeter. So we're going to divide 1 millimeter by 2. And that is going to give us 0.5 millimeters. First thing is to write down the lower bound length of the side. Here is the length of a side of an equilateral triangle, and their thing is to write the lower bound of that length of the side. So what we can do is we can calculate the lower bound of the side by subtracting the error from this calculated numerical figure that they've given us. So this is 41 millimeters. Subtract 0.5 millimeters is going to give us 40.5 millimeters. Next one. Giving your answers in centimeters, this is a really important step. Calculate the lower bound for the perimeter of the triangle. First of all, when something is asked for being calculated with its lower bound or upper bound, it's really important that we see whether it's direct and is mentioned in the question, or it's indirect and we have to deduce its formula and then calculate the lower bound. So first of all, we know that the perimeter is not given in the question. So what we're going to do is we are going to construct a formula for the perimeter. And a perimeter of a triangle, everyone knows, is a plus b plus c, and a plus b plus c is the same as sum of the length of all sides. And since this is the equilateral triangle and all its lengths are the same, so we are just going to write 3L and we're going to calculate. Now, we're calculating the lower bound of the perimeter, so we're going to multiply the lower bound length with the 3. So we're going to multiply, and we're getting 121.5 millimeters. They're saying us to give our answer in centimeters, and this is essential since this is 1 mark. If it would have been 2 or 3 marks question, then it would have carried 1 mark in its own. However, since this is only 1 mark, it's absolutely essential that you give the correct answer. We're going to divide it by 10 to give us 12.15 centimeters, and that is our answer. Moving on. So the next one, question number 2. This is obviously categorized topically, so we're going to solve the related parts in the question, and all of these questions in the topical series are basically either whole questions if they're totally related, or they are parts of a question that can be independently solved and are related to our topic right here. Here, this is the B part of this question that has appeared in the paper. John has a length of a string. He has a string of 4 meters long, and it is correct to 10 centimeters. So this is our accuracy. Hence, our error is equal to 5 centimeters. 10 centimeters over 2 is 5 centimeters. Write down the lower bound length of the string. The lower bound length, I'm just going to denote length by L, is this, the length that's given, 4 meters, subtract 5 centimeters. Now, notice that the units are completely different, so we're going to convert the bigger unit into the smaller one. And since they've asked us in centimeters as well, that further confirms that we need to convert this into centimeters and not this into meters. This is 400 meters. We're going to subtract away 5 centimeters, and that's going to give us 395 centimeters as our answer. The next one, the next part. John cuts off 10 pieces of string. So he cuts off 10 pieces from his string, and each piece is 5 centimeters long. This is the length of each piece of the string. Correct the nearest centimeter. This is our accuracy again. It's different, and it's not 10 centimeters this time, it's 1 centimeter. So error is 0.5 centimeters, again divided by 2, accuracy divided by 2. And find the minimum possible length. Now the minimum possible is always indicating us the lower bound. Maximum possible would have been upper bound. So find the minimum possible length of the string remaining. He cuts off 10 pieces, so the length of the pieces cut is going to be 10, since there are 10 pieces, into 5 centimeters. And they're saying us to find the minimum possible length of the string remaining. The string remaining is obviously going to be the original length of the string, subtract away the length of the pieces. So we need to find the minimum possible, so the lower bound remaining string, and that is going to be equal to original, subtract away length of the pieces. And since we're calculating lower bound, the original is also going to be lower bound, and the thing that we're subtracting, that is the length of the string, is going to be upper bound. We have already calculated the lower bound length of the string, and that is 395 centimeters. Subtract away the upper bound length of the pieces. Now, how do we find the upper bound length of the pieces? 10 is going to remain as it is, and the length of the pieces, one piece, each piece is going to be upper bound as well. And this is calculated to an accuracy is 1 centimeter and of an error of 0.5, of a possible error of 0.5. So we're going to add the error 0.5 into our length, and it's going to give us 55 centimeters total cut from the original. So this is the upper bound length of the pieces cut, so 55 centimeters. And if we subtract and find our lower bound remaining string, or the minimum possible length of the string remaining, we're going to find that it is equal to 340 centimeters. So that's our answer. I hope you've gotten it correct so far. Let's move on. I've solved this one, and now I'm going to explain. Question number 3 says, ABC is a triangle. I've drawn ABC, and angle A is 62 degrees. Angle B is 53.4. Angle A is correct to the nearest degree, so the accuracy is 1 degree, and error is 1 degrees over 2, which is 0.5 degrees. Then angle B is 53.4, correct to the nearest tenth of a degree, which also means 1 over 10, or 0.1 accuracy. And so the error is accuracy over 2, 0.05. Write down the lower bound for angle B. For lower bound, what we do is we subtract the error from the original measurement. So we're doing that and we get an answer of 53.35. Then we're calculating the upper bound for angle C. Angle C. Now, angle C is not given in the question. It's one of those indirect questions. So we're going to construct a formula. The formula for angle C is going to be 180 degrees, subtract angle A and angle B. And the reason for that is, if you're not familiar with angle properties, the triangle angle sum is equal to 180 degrees. So if you subtract angle A and angle B from the sum of the triangle's angles, which is 180 degrees, you're going to land with angle C. So I have written the same thing. And the next part is upper bound for angle C. So we have to not only calculate angle C, but also the upper bound. And to calculate that, we're going to subtract lower bound angle A and lower bound angle B. Lower bound angle B is already calculated in the previous part right here, and lower bound angle A can be calculated by subtracting the error from the original measurement, which is 62 degrees, and that is going to land us with 61.5. Then we can consequently subtract both of these measurements from 180 degrees to land with 65.15 degrees, which is our answer for part B. I hope you're getting it correct. Let's move on. So the next one, question number 4. Again, it's a part of it and it can be individually solved, so I've included it. An athlete ran a race in 9.58 seconds, correct to the nearest hundredth of a second. What is the shortest possible time that the athlete could have run the race? Now, the shortest possible time indicates lower bound, and the accuracy is 100th, which also means 1 over 100. But it's easier to write it as a decimal and calculate using a decimal, since fractions can make things complicated at times, so I have done it at decimal. However, if you do it in the fraction way, you should be able to solve it without a calculator, since this is paper 1 GCSE. So I've calculated the error here, 0.01 seconds over 2, and I've gotten 0.005 seconds. And the answer for the lower bound, or the shortest possible time, the minimum possible time the athlete could have run the race, is the original measurement. Subtract away the error and you're landed with the answer. Let's move on. Question 5. The mass of a bag of sugar is given as the 1.5 kilograms. Correct the nearest tenth of a kilogram, which means, again, 1 over 10 kg, or 0.1 kilogram accuracy. So we have to write down the upper bound of this mass, giving our answer in grams. Now you see this is kilograms and this is grams. What we can do is we can calculate with the kilograms, and then in the end we can convert it into grams, or we can do it in the starting as well. And so then our calculations would naturally go in the right direction to a grams answer. But I've done it the other way around. I have calculated with kilograms, and then in the end I have simply done one step and converted into grams. First of all, I calculated the error, which is 0.05 kg as we calculated it, and upper bound mass could be calculated by adding the calculated amount and alongside adding it with the error, and then we can get the upper bound. And then 1.55 kilograms can be converted to grams by multiplying it with 1,000, since 1 kilogram equals 1,000 grams, and then we can get our answer. Question number 6. The length of a side of a square is given as 57 millimeters. Correct the nearest millimeter. Write down the upper bound for the length of a side. It is similar to this question that we did here, the first one. So if you understand this one, maybe you can have a go at this one. Okay, now that you've done it, let's see if you've gotten it correct. First of all, we have to write the upper bound for the length of the side. Upper bound is always and always adding the original measurement with the error. We have an error of 0.5 millimeter according to a 1 millimeter accuracy, and adding it to 57 millimeters will give us 57.5 millimeters. No conversion required, so we're going to skip that step. Then we have give your answer in centimeters, calculate the upper bound for the perimeter of the square. Similar, very, very similar. For L, since the square has all sides equal, so we can represent one of its sides by L, and we can multiply it by 4 since square has 4 sides. We have to calculate the upper bound for the perimeter, and so an upper bound perimeter can be calculated by an upper bound length, right? And to do that, we have already calculated the upper bound length. If not, then we can calculate it and then find the answer. So I have an answer of 230 millimeters. I hope you have as well. Moving on. Okay, so question number 7. An empty lorry has a mass of 4.3 tons. A new unit. Correct the nearest tenth of a ton. Again, the same as 1/10 of a ton. What is the lower bound for the mass of the empty lorry? So this is the accuracy. The error is a half of this accuracy, and so it's going to give us 0.05 tons. Lower bound is the actual mass, the calculated measurement or the calculated mass. Subtract away the error, and that is going to give us the answer 4.25 tons. Then they say us to calculate, then they give us information as the total mass of the lorry and its load is 6.8 tons. So they're giving us the total mass and its load. So we're going to just assume that this load is X for now, unless they give us something. Correct to the nearest tenth of a ton. So again, the same accuracy, the same error. Find the upper bound for the mass of the load. The mass of the load, that is X, upper bound X, can be calculated by the upper bound total mass, subtract away the lower bound lorry. That is going to give us the upper bound mass of the load, or the maximum mass of the load. And the total upper bound of the total mass can be calculated by, so the total mass, upper bound total mass, is 6.8, add the error, 6.85, and the mass of the lorry, the empty lorry, is 4.25, the lower bound mass, which you've already found in the first part. Subtracted away, you get 2.6 tons as the mass of the upper bound mass of the load. Next, the length of a rectangular rug, okay, I'm just going to draw it a little bit visually, is given as 0.9 meters. To the nearest 10 meters, now 10 meters, centimeters is the accuracy, and so that is 0.1 meters. The error is going to be 0.1 meters over 2, which is going to be 0.05 meters. The reason why we convert it into meters is because this is given in meters, and we have to calculate this one as well in meters. So it's better to convert it. I've converted it, and we have to write down the upper bound in meters of the length of the rug. So the upper bound length is simply the length plus the error, 0.9 meters. Find the lower bound in meters, the perimeter of the rug. This is also a very similar question. You might have recognized that now that as we go along, the questions are of the same style and format. They usually give us one part which has a very direct upper bound or lower bound, And the second part, which is usually a indirect but connected nevertheless part, and we have to calculate the lower bound or the upper bound of that. So we can find the lower bound in meters of the perimeter of the rug by first of all, the perimeter is equal to 2 length plus 2 width, and the lower bound will be lower bound length and lower bound width as well. And I've done the same thing here, lower bound length and lower bound width. And I have added these together to get our answer as 2.8 meters. Let's move on. Now I'm going to move a little bit faster because now, as you might have noticed, the questions are getting simple and easier to understand and almost the same with a little bit difference. But where it's required, where the question is a little bit more tricky than the previous ones, I am going to explain in further detail. But I'm going to explain all of this nevertheless. Let's move on. So question number 9, the mass of the box is 2 kilograms, and it's correct to nearest kilogram. 1 kg is the accuracy, its half is the error, 0.5 kg. Write down the lower bound for the mass of the box. 2 subtract away 0.5 is 1.5 kg. You may do the working over here. I have not done so because just for the sake of this video and the length of this video. Then the mass of the can is 350 grams. Nearest to the 10 grams, which is the accuracy, error is 5 grams. It's half. Giving your answer in kilograms, calculate the lower bound for the total mass of the box. And 20 identical cans. Now this is not direct. They have not given us a total mass, calculated total mass of box and 20 identical cans. So we need to make a formula. That is, we add the mass of the box and we add the mass of the 20 identical cans, but it's lower bound. So we add the lower bound mass of the box and we add the lower bound mass of 20 identical cans as well to get 8.4. Next we have Sam and Tom ran 60 meters. Sam took 9.4 seconds, correct to the nearest tenth of a second. Again, 1/10, the same thing. Tom took 8 seconds, corrected the nearest second. That is 1 second is the accuracy. Oh, it's already written. Okay. Write down the upper bound for the time taken by Sam. Sam's accuracy is tenth of a second, and so its error is 0.05 seconds. The upper bound is simply error plus the original measurement, which is 9.45 seconds. Now, calculate the greatest possible difference. This is another key word. This indicates an upper bound between the difference taken by the time taken by Sam and the time taken by Tom. So simply subtract both of these together. But since they're saying is the greatest possible or the upper bound difference, Sam's time is going to be upper bound and the Tom's time is going to be lower bound. We're going to subtract less and add more since this is added nevertheless. We have 9.45 seconds as we calculated in the earlier part, and Tom's time we can calculate it using parentheses and easily do that to show the examiner a little bit of evidence that we did actually calculate the Tom's time, the lower bound Tom's time, and then we can subtract and get our answer as 1.95 seconds. Question number 11. The length of the side of a square. This drawing doesn't look a lot like a square, but we're going to go with it. The length of the side of a square is given as d, and correct the nearest 10 centimeters, which is the accuracy. The error is then 5 centimeters. Find an expression in terms of d for the upper bound perimeter of the square. Now here they haven't given the direct one, they've just given 2 of the indirect ones. So that's not much of a problem since we have been doing some indirect parts as well. Upper bound of the perimeter is d plus the error, which is 5. So that is the length of our side, and we can get the perimeter by multiplying it by 4, since there are 4 sides of the square. So this is our answer. Forgot to enter that here. This is our answer. The lower bound of the area of the square. The area of a square is L squared, or L multiplied by L. But we don't know how we can go. If L squared is a little bit confusing, or you don't know how to go along with that, you can just represent it as L into L, which is absolutely the same thing. Calculate the lower bound of the area of the square. Lower bound area is going to be equal to lower bound length into lower bound length. Lower bound length is going to be D, subtract away the error instead of adding it, and then it's going to give us a quadratic expression. We're going to just write it here. For this sort of a question, you need algebraic skills as well, so make sure that you go over algebra as well. It is an essential part of a mathematics exam, a high school mathematics exam generally, but really important in O-level or GCSE as well. So make sure you know that before coming on to this. Make sure you have a little bit of prerequisite knowledge. If you want any worksheets regarding it, we may provide that as well. Just pop them in the comments below. Then question number 12. In the diagram, AOB is 46. We can see that AOB is 46. AOB is 46. And AOC is 162. Right here. Their accuracy is the nearest degree, and both of their errors is 0.5 degrees. Write down the lower bound for AOB. We simply subtract the error and we get our answer. Find the lower bound for BOC. Simply subtract, BOC is a little bit indirect. BOC is this angle right here, but we know the one rotation is 360 degrees. If you don't know, I encourage you to revise a little bit of angle properties or go over the basic ones before you attempt this sort of a question. 360 degrees is the total revolution angle, and so we're going to subtract both of these to get this. However, they're saying the lower bound of BOC, so we're going to subtract more, that is, subtract the upper bound of AOB and AOC. We've calculated the upper bound and we have subtracted it accordingly to get an answer of 151 degrees. Let's move on. Okay, we're down to question number 13. I encourage you to pause the video and try this out on your own. Okay, if you've done it, let's check our answers. So first of all, a rectangular garden has a length of 35 meters and width 25 meters. These distances are measured correct to the nearest meter, 1 meter accuracy, and so an error of 0.5 meters. Write the upper bound length of the garden. Upper bound length is length plus the error, since this is upper bound, and then we get 35.5 meters. Work out the lower bound perimeter of the garden. Perimeter is 2 lengths plus 2 width, or 2 parentheses length plus width. And in order to calculate a lower bound perimeter, we can calculate the lower bound length and width. After doing that, we can multiply it by 2 and get our answer as 118. Next, question number 14. The time taken to run a race is given as 54.3 seconds. Correct the nearest 0.1 of a second. Error is 0.05. Accordingly, find the lower bound of the time taken. Just subtract the error. The distance run is d meters. Now, this might involve a little bit of algebra. The distance run is given by d meters. Correct the nearest meter. Write down an expression in terms of d for the maximum possible average speed in meters per second. Maximum possible, again, upper bound, and average speed is total distance over total time. The distance run is d meters. We can represent it by d, and since we don't have the exact time, we can represent t by time by t. We're calculating maximum possible, so we're going to basically calculate upper bound average speed, upper bound distance, and lower bound speed, lower bound time. And after calculating upper bound distance and lower bound speed, we can calculate, or we can express algebraically the upper bound average speed, which is this one. This was a little bit different, so I hope you get this one. Let's move on. Question number 15. An empty box has a mass of 0.8 kilograms. Correct the nearest 0.1 kg. It's the accuracy. I've calculated the error. Lower bound mass of the empty box. Subtract away the error. Next, the box is filled with books. The total mass of the box and the books is 6 kilograms. Correct the nearest kilogram. Work out the lower bound mass of the books. So I've calculated the formula, or I've denoted the formula right here, and I have then accordingly, for the lower bound mass of the books, I've calculated lower bound total mass and upper bound box mass, and I have subtracted them accordingly to get my answer. This is a little bit similar to that Lori question we had a few pages back. This one. So I hope you're getting these. Question 16. At an athletics event, Dave and Ed threw a javelin. Dave threw 60 meters, correct the nearest 10 meters. Ed threw 61 meters, correct the nearest meter. Write down the lower bound for the distance thrown by Dave. Simply subtract away the error again. And then calculate the greatest possible difference between the distance thrown by Dave and the distance thrown by Ed. Very, very similar again to the distance that question with Tom and Sam. Yeah, this one. So if you think you're confident with this sort of a question, give that one a try. I hope it's correct. Simply, we just construct the formula, and since this is upper bound, greatest possible difference, I calculate an upper bound for Ed and a lower bound for Dave, since we're taking Dave's distance away. And our answer is right here. Question number 17. The aircraft flies a distance of 3,200 kilometers. Correct to the nearest 100 kilometers. Write on the lower bound distance. This is very, very simple again. Subtract away the error and we will find our answer. Question 18. Okay, now this one, I'm going to encourage you to pause the video again, because in this one, we have another formula construction, and I want you guys to try a whole question by yourselves. Okay, if you've done it, I hope you've gotten the correct answer. First of all, the lower bound mass of sweets. I've calculated the accuracy and error, and then I subtract away the error. And then I have a formula construction. Since it's the lower bound mass of sweets, I calculate a lower bound mass of a total mass and upper bound sold to get the remainder, and I get 340 as my answer. Question 19. Again, very, very simple. It's a lower bound. I hope you guys can understand my working, because it's pretty simple. Just calculate the accuracy, calculate the error. If it's a lower bound, subtract away the error from the original measurement, and if it's upper bound, add away the error in the original measurement. Question 20. A box has a mass of 1.7 kg. Correct the nearest 0.1 kg. That is accuracy. Write down the lower bound simply again. We have a formula construction, very, very simple and very, very similar to the previous ones. Here is the solution. Okay, this one is again a formula construction and an upper bound. It's about temperature, so that is what we have here. Now this one has a negative integer. A negative integer is entertained the same way as a positive integer is done as a measurement. So we're going to add the error in the case of an upper bound and subtract it in the case of the lower bound. We have a very, very similar one again. Now this time it's a little bit different. For the formula construction, this is the area given and they're asking the width. So it's just dividing the area with the width in order to get the length. And since we're calculating a lower bound length, we're going to calculate lower bound area over upper bound width, and that's going to... So then we can get our answer. And we're down to the last question. Okay, the last question, I'm challenging you guys again. Calculate it and then come back to me with your answers. I hope they're correct, because this is a simple lower bound of the length and the perimeter, which was very, very similar to our first and the first few questions. So I hope that's correct. I'm going to share with you the marking schemes as well, so you can counter check and point out if I made an error, because it's possible as well. Question number 10 to 17. Question number 18 to 23. I hope you got most of these correct, and keep practicing, keep solving. I'll see you guys later with another video. Don't forget to subscribe so that you can be notified if I post any new videos regarding these math papers and any economics or accounting papers as well. If you have any subjects on request, we can do that as well, so please pop them in the comments. Question us, because we love questions. Okay, see you guys later.